Hi there, today we're going to go over bonds. Bonds are financial instruments primarily used by government entities and corporations as a means to acquire large amounts of capital. They're doing this by picking up debt. So it's analogous to the same way you would go out to a bank and ask for a loan. They're doing the same thing, but they're asking the public market, which is everybody who's willing to give them money, just like me and you. And in return, they're going to promise to pay you back the face value. And the face value here is the loan amount, the amount of money you gave them. They're promising you that back. And they're also promising coupons. And coupons are periodic payments that are equivalent to like an interest rate. So the amounts of interest each year your payment would have received if it was instead in a bank account. It's usually higher, though, to incentivize you to give them money, right? So bonds are one way to raise money. There's also a counterpart to raising money that's similar to bonds, but it's stocks, and we've all heard about stocks. Stocks are another way to raise capital, but you are not picking up debt. You're instead selling ownership of your company. So when you're making the decision about whether you want to sell bonds or stock, you're usually weighing out whether you want to sell ownership or if you want to pick up debt. Another fun fact is bonds are, in the investment world, generally thought of as a very, very safe investment. And because of that, insurance companies generally have 70% of their portfolio made up of bonds. So here I drew out a little schematic to help you visualize what it's like when somebody gets a bond. Here we have a government institution or a corporation. As you can see, it's pretty big, well established, and it wants to borrow money. Can I borrow money, it's asking? And here Sir Walter Elliott, or he's just symbolic for somebody who's wealthy and interested in investing money. He's going to capitalize on this opportunity and provide money. Here we have money. He's exchanging money now for delayed payments or a bond. It's an investment. So you're essentially giving money today so you will receive something later. And here we have on the bond, it has the face value, the amounts he paid that he will be promised back in return at the end of the term. And attached to this, in the old days at least, there were coupons, which is where the word coupons come from. And you would essentially, when they're eligible to be redeemed, you would go to some bank and get the amounts of the coupon every period. In this case, though, or in today's time, it's all done electronically, so there's no longer a physical coupon, nor is there a real physical bond. But the terminology is stuck around, so we're going to use it. And now we're going down below. We have this timeline at time 0. He's kind of just waiting. There's this clock, there's some ticking and some talking going on. And then eventually he's just waiting for his time to redeem a coupon. So at time open interval 0 to closed interval n, the half open interval, he's going to pick up coupons. As time goes by, he's going to keep on acquiring every single coupon that he was given. And he's going to be very happy. You notice he has a smile. His mustache is still doing pretty well. And then at time n, he's going to receive his entire investments amount along with one extra coupon. You can't forget that. He's going to receive one extra coupon at time n. And that's how bonds work. Here we have some a notation I want you guys to be familiar with. You can pause the video, obviously, but let me just walk you through some things. P is the price of the bond, so the amount that somebody would buy it, say, after it's in secondary markets. So in the schematic case, he paid the face value amount, but if he wanted to sell this bond somewhere else in a secondary market, like people usually do with stocks, bonds have their own market, he will sell it at a different price depending on how the market will equalize, right, and what they would value that bond at. So price isn't necessarily equal to face amounts, and that's why we have two different symbols for those things. F is the face amount, and it's also called the par value for reasons I am unaware of. C is the redemption value, so C is the amount that Sir Walter Elliott would receive at time n. It doesn't have to be the face value. Sometimes it is a difference amount than the face value, but unless otherwise stated on the exam, the face value is assumed to be equal to C. So most of the times, like I said, you could just assume these two to be equal. R is the coupon rate. The coupon rate is, I guess, the percentage of the face value that you will receive as your coupon. So coupons can be evaluated as F by R, F times R. So after you multiply these two amounts, you would get your coupon amount, so the amount that Sir Walter Elliott over there would receive. G is your special coupon rate, and this is a fabricated symbol. It's mostly there to help with mathematics. I hardly use it, but we'll see it come up every now and then. So it's the amount that if you do have a difference redemption value, if your C differs from F, it's the amount that you would have to apply to C so that it's equal to the coupon that you receive. So this is equal to the coupon. And it's the amount that you would apply to your redemption value so that it's equal to the coupon. It will come in handy, we'll see. N is the number of coupon payments, and I is the yield. Now, you might be asking, what's the difference between R and I? And this is a nice segue for our next big key point. So R is fixed. It's inherent to the bond. The coupons are constants unless they refinance. So you can assume that R is definitely very fixed, more so than I. I changes based on the price that the bond was purchased on the secondary markets. So like I stated here, P doesn't have to be F. Of course, in this case, in my schematic, he probably did pay the face amounts, but when he goes out to the secondary markets during this time, he might sell it to a friend for more than the face value or less than the face value. And with that in mind, I will differ because now we have to value the series of payments with a different present value, and I might be higher or lower than R. So we'll see that all work out in the mathematics. So we're going to go over our first example. I'm going to stop here. So here we have an example. We're just going to go over the anatomy of a bond when it comes to how they describe them on the exam. And it's pretty simple. Here we have a $1,000 bond and with 8% semi-annual coupons maturing in 10 years. So in this small description, we have both the face value, the coupon rate, and the term amount. This would be the face value of $1,000 bond. So we can write that in there, $1,000. The coupon amounts would be here, 8% semi-annual. So we have 8%. And whenever I write this on paper for an exam, I like to divide it by 2 just to remind myself that it's semi-annual. And N here is 10 years, so we're going to fill that in. And here we have the timeline that's associated to this description, and we're just going to fill it in. So R, when it comes to bonds, when it says semi-annual, I know we're used to converting that to an annual rate, but we actually just leave it as 4% because you're actually going to receive coupons at a on a semi-annual basis. So to compute what the coupon amount is, we just have to multiply F by R. And that is equivalent to 40. Yes. So now we're going to fill out the timeline. Like I said, you receive payments, coupons within every semi-annual period. So we're going to receive 40 here, 40 there, 40 here. So I like to denote my years with the parentheses of 1 under wherever a year begins, just to keep that in mind. Here we have at the end, on the 20th period, it's the 10th year, so that's where we're going to receive the face value, because that's what it was stated as. The face value was $1,000. They didn't state a different redemption value, so we're assuming that that's the amount you're going to receive on the 10th year. So you're going to receive 1,000 plus, like I mentioned, another coupon. So this is what the timeline would look like for that specific bond. So we have another example of a description of a bond. We're just going to find what the face value is. So here in this case, the face value is $110. The coupon rate is 5.5% annual coupons, and the term amount is 10 years, underlined here. And the coupon amount is F times R as usual, and that turns out to be $6.05. So now we have all the information to fill in our timeline. We're going to receive $6.05 every period. And on the 10th period, we're going to receive our redemption amount, $110, plus another coupon. So I'm just trying to get you guys in the habit of how to identify each key element of a bond. And just remember this fact that you do receive a coupon at the end of the term along with your redemption amount. So referring back to one of the timelines we already created in example 1, how would you take the present value of these series of cash flows? Well, you would take the present value of each coupon along with the redemption amount. And the coupon payments can be thought of as a geometric progression with the interest rate, kind of like an annuity. So you can think of all the coupon payments collectively as a big annuity of amount 40. The level payments would be 40, and the $1,000 is just something you have to add on. You have to take the present value of this all the way down to times 0 to know what the present value is. So this all translates to this plug and chug formula. The present value of a bond, aka the price of a bond, is equal to FR denotes coupon amounts like we've seen. This is the coupon amount times an annuity factor, A angle N, plus that redemption value, don't forget about it. You have to take the present value of it all the way back N years, and the sum of these two things will equal the present value of the bond. So we are going to refer back to this formula to do some of our other examples coming up. So I just want to go over some commonly used terms, the three being par, discounts, and premium. So par is a word that they use for bonds that implies that you purchased your bond at face value. So if you purchase something on par, that means that the price was equal to F. It also implies that your coupon rate is equal to the yield. And you'll notice that there's a relationship with what the price is compared to the face value and how the coupon rate relates back to the yield rate because of that. So in a discount case, that means that you purchased a bond with a price that's lower than the face value. So it looks like you're exploiting a good opportunity. And when this happens, that implies that the coupon rate is lower than the interest rate or the yield. And when in the premium case, you purchased your bond at a price that's higher than the face value, and this implies that the coupon rate is greater than the yield. So let's go over an example that has all of the bells and whistles. Here we have a 10-year bond with coupons at 8% convertible quarterly will be redeemed at $1,600. The bond is bought to yield 12% convertible quarterly. The purchase price is $860.40, and we want to calculate the par value. So let's refer back to this. We want to identify the face value, which is the variable we're interested in. And in order to do so, we have to now somehow identify in this pile of complicated words, we have to translate that into NRC, IMP, all the notation we just learned. So let's find N. N in this case is a 10-year bond. So a 10-year bond means that the term is 10 years. So we can go back to N and fill that in for 10 years. So let me use a different color Sharpie. 10 years. We have 10 years. So the coupon rate here is the coupons are sold at 8% convertible quarterly. So this is your coupon rate. It's 8% convertible quarterly, which amounts to 2%. if you continue reading, this bond will be redeemed at $1,600. So this is your redemption value, and it differs from your face value, obviously, because they're going out of their way to say that the redemption value is something else. So here we do have the case where C differs from F, and we could just fill C in as $1,600. So if we continue reading, the bond is bought to yield 12%, convertible quarterly. So yield is a key word here that indicates to us that this is equal to I in our notation, and it's 12% divided by 4 since it's convertible quarterly, and this is equal to 3%. And if we continue reading, the purchase price was $860.40, so we can fill in P because that's the amount that they paid for this bond, and we want to know the par value. So we have all the information now. We dissected this passage, and now we can do some math with this information. So this is what we got as the given information. Now we're going to use our plug and chug formula, this thing here. So let me fill out the timeline so you guys can have a visual of what's going on here. So we have R here, and we're receiving coupons that are equal to F times R, because that's what the coupons are equal to, F times R. But we don't know what F is, so this is still, we do know what R is, so this is just equal to 0.2% times F, and this is your coupon amount. This is, you're going to receive this, FR, at every quarterly interval, so every 3 months. And like I said, I like to denote a 1 year period by having 1 in the parentheses underneath 4. And you're going to have 40 payments, so you're going to receive a coupon here too, but at the same time you're also going to receive your redemption amount, which is $1,600. And you want to find out what the face value is if you, for these series of payments, paid P being $860.40. So we can solve for this by just using this plug and chug formula here, right? Do you kind of see where I'm getting at? So P is equal to $860.40. We don't know what F is, but we do know what R is. And we get 40 coupons, so N here is equal to 40, as we had here, 10 years, but you know, we're dividing those up by 3-month periods, so it's 40 years, plus C, which is 1,600, VN, or 40. So you can solve for F in this equation, and it turns out we get 815 cents is the face value. So the face value is equal to 815 cents. And I encourage you to do this on your own so you can kind of test if you're doing the calculation correctly. Other things you want to look at now are bond lingo. So there are some things that might sound bizarre, but I'm going to try to relate them back to things you already know. So here we have book value. So when we say book value, I want you guys to hear outstanding loan balance. So book value is similar to the outstanding loan balance in the amortization we did with normal loans just a couple weeks ago. The amortization of a premium is just equal to the principal repaid. It's just a different phrase they use for the same thing. And accumulation of discounts is equal, you should hear writing up, but this doesn't sound, or really doesn't compare to anything we used to do. In this case, we'll look into this a little bit more in depth actually. So I just brought up the words principal, amortization of premium, and accumulation of discount. Well, these words relate to the amortization of a bond that's purchased at a premium. So when you purchase a bond at a premium, like I mentioned, you purchase a bond at a price that's greater than the face value. And this does something interesting to your amortization table. And I'm not going to draw out a specific example. I'm just going to show the pattern. So if this is your amortization table, we know that coupons stay constant. So this entire thing all the way down is going to be constant all the way down from time 0 to n, whatever time your bond ends at. And you purchase the book value. The book value is your outstanding balance, as I told you guys to translate it to. You purchase the bond at a premium. So this amount, A times 0, this is a very big number, or it's equal to bigger. I'm going to note it as bigger because it's bigger than the amount you're going to receive at time n. This is just your face value. So you purchased it at an amount that's bigger than the face value, right? And the pattern is that when you multiply your bigger amount times an interest rate, the interest rate that, remember when I said you purchased a bond at a premium, you have a higher interest rate. Do you recall that? No, I take that back. You have a lower interest rate than the coupon amounts. So you're going to multiply your bigger amounts in the face value by a interest rate that's smaller than R. And usually that's going to amount to having something that's less than the coupon. So you're going to have interest that you pay that's smaller than the coupon. Say the coupon is 40, you're going to pay 30 or so. So that's going to leave money for the principal repaid. So that's going to be like $10 for you to repay this bigger. And $10 will be now subtracted from your bigger for the following period. And you're going to notice that premiums will continue to grow. This will get bigger as well. 10 will go to 11, and accordingly, interest will drop to 29. This is just a pattern I'm trying to demonstrate, and bigger will eventually become the face value. Each time you pay the premium, it's going to decrease it to the amount of the face value. That's the whole big idea about the amortization table of a bond purchased at a premium. And this is usually also called the write down. How much do you write down each time or write down at time t? It's a question they might ask you. Now we have a bond sold at a discount, and this is a little different. Here you don't have bigger, you have smaller. At time 0, you have smaller. Your P, your price, is smaller than the face value. So this is all the way down to time n. Here we have face value. And your coupons are consistent, or constant again, constant. We can say they're 40. Time 1, they're 40. So remember, going back to this note here, when you purchased at a discount, not only is your price lower than the face value, but your interest rate is greater than your coupon rate. So since your yield is greater than your coupon rate, your interest is going to actually be greater than 40. It's going to be, say, 50. So that's kind of strange. How do you have an interest that's bigger than the coupon? That means they owe you $10, but they're only giving you, they owe you $50, they're only giving you $40. So where does your $10, where do your $10 go? Well, your $10 are actually going to be used as the accumulation of discounts. So usually this is a negative amount that you're going to subtract from the book value, but since we're going to call it a discount, we're just going to look at it as a positive amount. And this is going to be added to your smaller amount, so smaller, or you're subtracting a negative, but that just results in being a positive number. Smaller now gets kind of written up, and that's the word I just described here. Accumulation of discount means writing up. And we're going to write up the amount that you purchased it at, smaller, by that amount, the corresponding amount of 10. And the idea is that we're going to continue to add the principal to smaller so that it eventually turns out that at time n,